Good morning, everybody. Today I would like to spend some time talking about weather stations, setup, location and data usage. So I thought it'd be quite useful to go over some basics behind choosing a weather station, why you might need a weather station, where you might want to locate a weather station, and also what the weather station can actually provide you with. So we've set up a little presentation and we'll step through it and talk about some of the features as we go along. We'll move on to the first slide. Okay, so some important points that we'll cover. Why should you consider purchasing a weather station? What can a weather station measure? How are they powered? How do they send data and how can you access it? Location, location, location. That's probably the one that I would almost highlight more than any of the others at the moment. Trying to find that perfect location to locate your system is key to getting good data. And I think I'd like to say that bad data is actually worse than having no data at all. Different systems and associated costs, some troubleshooting, using weather station data to improve your turf management and ideas related to that. So why should you consider purchasing a weather station? On a general level, to measure climatic variability. So here we have some charts. On the left hand side, as I'm looking, this one over here, we can see that that was from sort of December the 16th, 2024, so last Christmas. And I'm just going to step back because I need to read something. So the chart on the left hand side from Christmas 25 shows a warm air peak event. So as we can see, the warm air plume that is coming over the country. Now we'll look at some data further through the presentation that actually relates back to that, and it shows us how we managed to track some disease pressure that actually related to that change in climate, the increase in that hot air plume that came over the country, which is an interesting feature. And then on the right hand side we have come on, blimey. Down a cut off low. I'm telling you. A Dana event. Okay, so on the right hand side, we can see this is from mid-September 2024. And this is where we had what's called a Dana event. So we had pressure building over the Bay of Biscay. And then we can kind of see we've got this green mass that came over the UK, and that's when we had exceptionally high rainfall during September. And then what we'll be able to see when we look at the data, we'll be able to see how our data reflects that event. So this is basically how that climatic variability that we're dealing with affects the weather on our courses, on our sports locations, on our farms, etc., and how our weather stations are then interpreting this data. So again, why should you consider purchasing a weather station? Okay, so one of the key features, irrigation management. So we can use our weather station data to look at how our irrigation needs to be managed. Do we need to irrigate? Do we not need to irrigate? How well has our irrigation worked? So we can measure that. We can look at things like ET, our evapotranspiration, and build that into our irrigation management plans. So that's going to help us irrigate more effectively, save costs, and improve the condition of our courses and sports turf. Extreme weather data recording. So I don't know whether anybody can see that, but we actually have I think that's the fourth hole somewhere. As you can see, it's got a severe water feature. So again, we can start recording our extreme weather events, whether we agree or whether we don't agree with climate change. One thing I think we can all agree on is that we are actually seeing more and more extreme weather events as we go forward. And then finally, we've got dew management. Why is dew management important to us? So we can see we've got one of our leaf wetness sensors up there. So dew management is one of the key drivers to disease management. So we'll look at some of the diseases that we're able to monitor and start to predict when we go through the presentation in a bit more detail. And obviously rainfall and rainfall rate data. So here we can see a washed out bunker. So what we're able to do by monitoring the conditions, and then you're looking at your course or your location, then you can start to go, well, if I've had this amount of rainfall and this rainfall rate, then I know I'm going to have issues with my bunkers, for example. So you can start to decide on management practice, whether you're going to have to put more people on bunker maintenance, etc. And finally over here, as we're talking about, very much related to dew management, disease management. So again, we're starting to put disease forecasting into our product line as well. And probably most importantly, and above all, communication. We're able to communicate with our patrons, for example, our customers. That might be at a course level, so the people that are coming to play. It might be management. So we're actually able to take our data, present that in an understandable format, and then we're able to give people that information. So, you know, it's facts and figures rather than people maybe putting your finger in the air going, well, it was this, or it's that cold, or whatever, or somebody going, well, it wasn't that wet, why are the conditions like this? Well, actually, we now have hard and fast data behind that to prove facts and figures, basically. We're going to look at some climatic data from September 24. So what we're specifically looking at, and this is, if you remember when we were looking at the moving graphic where we were highlighting the rainfall event that was taking over the country in September. And one of the things I'd like to point out that we measure, so we're measuring on the column there, we're measuring millimetres of rain that we're getting in the day. But what we've also got is, and one of the key factors, is the fact that we're able to measure max rainfall rate and the time that occurred. So as we can see, for example, there we've got 5.6 millimetres for the day, but we recorded a 23 millimetres an hour rate at 9:45. So again, 18.8 millimetres with a 48.8 millimetre rainfall rate. But one that I'd like to highlight down here, might not be particularly clear on the video, but we had a rainfall total of 12 millimetres, but at 7:30 in the morning we actually had a 274 millimetre rate, which is intense to say the very least. So this is you know, useful information to feed back. Anybody sort of that might have been in that turf area or on the course or something like that, that time of the day, or after that event, might go, well, why is the course so wet? Well, yeah, we've only had 12 millimetres during the whole day, but that rate is what actually causes the damage and causes what needs, you know, causes the repair issues. So when we're able to give that information to our course owners and our management team and the patrons, that's what's really useful, and we can use it as well. You know, for example, if you had that rainfall rate at 5 o'clock in the morning, and we're displaying that, well, you then know that there's going to be on that turf, there's probably going to be some repair that needs to be done or some drainage issues. So high intensity rainfall events. At what rain rate do your greens flood up? So if you start to see flooding greens, like the picture on the left, we're able to then go, well, what was the rainfall rate at that time? So that's giving us that data that is causing the flooding. So in future, we can then start to look, and if you're getting that overnight or any sort of periods when the course is closed or whatever, we're able to predict that, you know, or you're able to use the data to predict what issues you're going to get flooding wise. At what rain rate do your bunkers wash out? Again, we're able to use the data. You know, you're using the data, comparing that to what you're actually seeing on course, and then we can correlate to what you're seeing with the data. So over here, total rainfall 31.8 millimetres, but the maximum rainfall was 112 millimetres per hour, and that's linked us back to what we've actually seen on the course. And then 25 minutes later, because on this specific course, they've really invested heavily in certain in drainage and that sort of thing, and ways to manage the extra high rain rates. Then 25 minutes later, it's all drained away. But again, we're using that data to feed back into that decision making. Maybe it's an area that you need to look, that you actually need to have drained. So again, we can use the data to pull back into that and use to give to management and make informed decisions. So what does our weather station measure? What's our standard setup? So our standard setup is having the weather station mounted 1.5 to 2 metres above the ground. That's where we're looking to all our sensor data to be recorded from. So anemometer, which we've got up the top. So wind direction and strength. When we set that up, the arm of the anemometer, which actually is the pointy bit there, the angled bit, that needs to face north. And then we've got a solar radiation sensor on there, which is just to the right of the rain cone. Solar radiation sensor allows calculation of ET, so evapotranspiration. That's done in pairing with the data that we're getting from the temperature humidity sensor, the anemometer, and the rain gauge. So that's giving us that ET data calculated using the solar rad as well. Quite often this is missed. Anybody who's looking at any sort of irrigation management or anything like this, one of the key bits of data is going to be ET. Then we have our single tipper rain spoon in there as well. So that's 0.2 millimeters every tip, and then a temperature humidity sensor in the shield at the bottom there. So some additional sensors that are proving very popular and are useful in your management practices. A leaf moisture sensor. So that sensor is actually should be a 6420, not a 6720, not a 4720. But the leaf wetness sensor measures leaf wetness on a scale of 0 to 15 using electrical conductivity on that little plate there. Quite a small sensor. So that works on a scale of 0 to 15, 15 saturated, 0 bone dry. Anything above, say, 6 or 7 on that scale, and then potentially if you were putting an application on, you would start to see runoff on the leaf. But the other important thing that it also gives us is leaf wetness minutes measurement. So how long your leaf is wet for, and we'll talk about that maybe a little bit more as we go along. But that length of leaf wetness is again one of our key drivers into disease. We have an apogee PAR sensor, so that's photosynthetic active radiation. So that's your grass growth light levels. Some courses and some areas, a stadium for example, where you've got shady areas, really useful to compare your shaded areas to your open areas. Especially when it comes to management, because we can start to look, well, how do we need to compare our shaded areas to our non-shaded areas? So are we having to handle that differently when it comes down to, for example, growth regulations or growth regulators, or when it comes down to putting on specific fertilizers, that sort of thing, or even when it comes down to tree management? We can start to say, well, because the sensor measures DLI, so daily light interval as well. So we can start using our DLI to look at what grass types, whether that be a bent grass or a pole or whatever, what light levels we've got, and are those grasses actually getting enough light in that specific area to grow. So that's using the apogee PAR sensor. Then we've got 6470, which is a soil temperature sensor. And then we've actually got the Teros 12, which gives us soil moisture, salinity and temperature at a specific depth, or we can put those in at multiple depths. So again, very useful for irrigation management. We can put those into the green or whatever, bury those down at about 10 centimetres, and then run the cabling back to the side of the green. So these are the sensors that we fit most often, but we do actually have with our Davis Enviromonitor gateway system, or IP gateway system, location and connectivity. So we have different connectivity options available, which is another one of the key Davis features that a lot of other systems don't actually have. So our subscriptions, depending on what we're going for, starts from £45 a year. So that would be a standard setup there. We've got the Davis Vantage Pro 2 6820, so that's your standard Davis VP2 weather station with a solar radiation sensor fitted, and then that's being connected back to your WeatherLink Live hub, connected to local Wi-Fi in a clubhouse or a maintenance facility, or somewhere around a stadium, etc. The weather station must be within 300 meters line of sight of the WeatherLink Live hub. The little WeatherLink Live hub is the device circled up the top there. So that requires mains power, whereas the weather station itself is self-powered, and all the data goes up to the cloud, either via your Wi-Fi or you can connect it to Ethernet. The other option, which is the most expandable option, is the cellular gateway. So subscriptions start there from around £200 a year. So again, we've got the same weather station connected, the 6820, but this time we've got the cellular gateway, which is highlighted there in the box. Again, all self-powered. All you require is sunlight at some point, and then a cellular connection. So that's not tied down to any specific network. So that's not tied to any particular network. The weather station, as we can see here, can be sited anywhere on site. There is a cellular connection, 3G, 4G, 5G, and the data again becomes cloud-based and then available on your PC and your smart device. So wireless connectivity over there, cellular connectivity, doesn't matter which. Our data goes up to weatherlink.com and then is available on the WeatherLink mobile app, which is available on iOS or Android. And that can be downloaded onto as many phones as you want. And then we have a snapshot of the data that we're getting off one of those WeatherLink mobile apps. So we've got our current rain data and a snapshot of our current conditions. And they would be updating every 15 minutes standardly. We can go 5 or 60 if we want to. So the PC output, again, the data also is available on the WeatherLink portal, so specific username and password. And we've looked at setting some of these up in some of our other videos. So this would be our snapshot of a bulletin. So depending on what sensors we've got, all the sensors are then displayed for viewing. The data can be exported. We can also set, some people are really interested in this, we can set alarm notifications. For example, if you had a requirement to have a wind speed alarm, so we might say that our course or our location is closed over 25 miles an hour, then we can have an alarm message go out to our course management team to let them know that they need to close the course and let people know that they need to get off the course. We can have that on rainfall rate, low and high temperatures, so there's a lot of flexibility on how those alarms can be used. So as we pointed out at the start of the presentation, location. This is the key to getting good data. So for example, our weather station set up there, great location, unaffected by shade, a good line of sight back to our WeatherLink Live hub, clear to the south and southwest for ET and rain measurement, so you're not affected by any trees, any buildings. We're also on a level piece of ground, so we need to be nice and level to get accurate sensor data, specifically when it comes to the rain gauge and also the anemometer at the top there. So that is a perfect location. So that would be between fairways, for example. You know, we do spend an awful lot of time when we're either at the pre-installation phase, when we're sitting down with customers. We'll normally go on to Google Earth or Google Maps, and we'll spend time looking at that overview of the site, talking to the individuals running the location, trying to find that good location before we actually get to site. And that's probably the bit that can actually take the longest, trying to find that location. So here we go. On the opposite scale, here is an absolutely awful location. I can understand why people have done it in the past. They think, well, we'll put the weather station up on the roof, but that's, you know, if all we have to say is, well, are we playing golf, or are we looking at our turf at that height compared to that height? No, we're not. So it will over-report wind and ET figures, because you'll actually be getting heat in the summer. You'll be getting heating from the roof, so your roof will warm up. You'll get the heat off that. Will also then start affecting the temperature, humidity. You know, potentially on there you've got a high rainfall event. The rain will actually be splashing from the top of the roof into the rainfall bucket. You know, sheltered by the building and potentially thermally compromised as well. Obviously, a lot of maintenance facilities and buildings are now metal clad, and they will also have insulation in. So, you know, the sort of insulation board that's got silver foil wrapped around it, that can actually compromise wireless distance between our, for example, WeatherLink Live hub and our weather station quite drastically. So You know, we've said there that our metal buildings almost act like a Faraday cage. You know yourself that if you're trying to use your mobile phone signal in one of those buildings, it's very difficult to get a signal. So the signal strength when we're on Wi-Fi in that particular area can be reduced. There are ways that we can get around it and help. You know, we can actually mounting the WeatherLink Live hub higher up. Some people have actually cut a section out into their cladding and put the hub near that. But if we can't find a location that's then within range, then obviously we have the ability to go cellular. So third-party installation. If you're installing yourself, this is one of the key points that we would point out just to be aware of. Everything is in the manual, but as we well know, not everybody likes to read a manual. So we do offer installation service throughout UK, Europe, on a bespoke package that allows us to ensure that the weather station is fitted as required, all the sensors are in the right place, the data's uploading, and then you're trained in the use of the data and also any maintenance required. But if you are setting it up yourself, a couple of key points: anemometer arm needs to face north, solar panel for weather stations on all other solar powered sensors or gateways, they need to face south, unobstructed as well, so they're getting as much sunlight to allow for good charging. We recommend use of the Sunseeker app to determine worst case sun angle and scenario in the winter solstice. So that's a really useful app that we use a lot just to work out where the sun's going to be at certain times of the year. As we can see on there, that's available on your app stores. And here's an example of where we've used that Sunseeker app to basically locate our station to get the best solar charging. So we want to make sure that the tripod's fully extended, and that as we can see there, we've got a bubble gauge on the base of the rain gauge. So when you take the rain cone off, you can see the base of the rain cone. So that's a really good guide to make sure that you're set up there. Just pointing out with those as well, the solar radiation sensor also has one of those, and that can be individual adjusted as well to make sure that's level. And if we don't say any further in the presentation, the tipping spoon always comes pre-delivered with a cable tie around it, and it wouldn't be the first time that somebody's not cut the cable tie, and then after a few days they'll go, well, we've had lots of rain, but we've not actually had any rainfall measured, and the cable tie is still intact. There is a tag on the side of the weather station that says remember to cut the cable tie, but it seems to be a simple thing that people do forget to do. So as we've said, you know, make sure before we make the system live that we cut the cable tie. I mean, that's another thing just to reiterate, that if you're configuring the system, I normally say put it all together in an area, for example a desk or somewhere like that, so you can make sure everything is installed properly, all the bits are put together, all the individual screws are in the right place, rather than trying to do it in the middle of a field. You know, when you drop your sort of 3-4 millimeter washer out there, you're not going to find it. So just do it all inside, get everything connected up. But then if you have still got everything running, just maybe unplug the rain gauge sensor before moving it out to site if it is all still live, because you know you've got the potential that will be tipping backwards and forwards, giving you false readings. Data generation, improving customer relationships. Okay, so let's talk about some of the data that we're getting out of the system and how it can impact at your location and how you can be using that data. So let's specifically talk about the PAR sensor. So there's a picture of our apogee that we were looking at a little bit earlier. So we're going to look at DLI, so our daily light interval. So we've got a DLI in 2022, DLI in 2024. So that is from 2022 and there 2024. So you can see on average how much difference there was between those two periods when we were measuring DLI. So look at the differences. In December, 24% light. November, 12% light. Less light. October, 21% less light. Well, that's going to have a massive impact on our management. Let's look at our photosynthetic active radiation data when it comes to some specific grasses that we've got there are bent, for example. And so there we've got our growth light level. At what, you know, beneath that line there, we're not going to get grass growth. And again, look at where we are. So let's have a look at our monthly agronomic summary. So over the right hand side here, so on the right hand side here, we can see how we're calculating. We've got growing degree days, cumulative annual growth degree days, 0 and 6 degree base, and then we've got our cumulative annual GDD in a 6 degree base, growth potential in this column, and then cumulative growth potential, and then we've got our SK probability, our Smith-Kearns for dollar spot. As we can see, we haven't got any of that showing up on this one, so no dollar spot. This was from January this year. So this would just be a rolling data that's automatically generated using our Pro Data Report software. So what we're doing is we're taking the data from the Davis database of the calculated values that are there, or the recorded values, and then we're creating our own data and presenting that to you using our own bespoke Pro Data reporting software. So what we're going to look at 2022, 23, 24, 25, looking at January specifically. So there we have 2022. Overlaying 2023, overlaying 2024, and then let's see what happens when we put 2025 into it. So look where we are so far in 2025, how our GDD is very, very low compared to the 3 previous years. So that's obviously going to have an impact on where we are going into spring. We can see sort of as of 20th of February, we've started to pick up, but even then we are still that much lower than where we were. You know, we can kind of see there's a little bit of correlation here and here, but it does allow us to calculate and view how our GDD is much lower this year. So, you know, we're looking at that as a 6 degree base value. So that's quite interesting. You wouldn't have maybe thought that January was that much different to previous January, but we are that much lower. So again, using the data, we can start to build our maintenance and our planning into that. We're talking about leaf wetness is being a key disease driver. You can see our different types of disease that we've got there. Let's have a little bit of a think on how leaf wetness is causing foliar pathogen activity, air temperature, relative humidity, dew point temperature, all of those building into leaf wetness. So one of our key measurements is leaf wetness minutes. So we can see in 2022 at this location, we had 73,553 recorded leaf wetness minutes. 2023, 107,061. 2024, 105,783. So these are very comparable. But what we've noticed with reports coming back from the course and from managers, and what we've seen with our own eyes, is how, for example, dollar spot has increased as a disease in the past couple of years. Well, we can link the severity of the disease and how it's becoming more common with the way that our leaf wetness minutes has increased. So one of the key measurements that we use is that leaf wetness minute data. Within our Pro Data reporting software is disease modelling. So we're using climatic parameters taken into a model and converted into real-time disease pressure. So here is some of that data basically graphed out. So this is the Microdochium nivale disease pressure model that has been developed by Mark Hunt. Most people will be aware of Mark. So as we can see, and this is where we have to go back to one of the earlier slides showing that graphical model of the Christmas period where we said we had that kind of heat plume that came over the country. Look where we've hit on the disease model that corresponded with that plume from like the 24th through to the 29th of December. We can see where that, taken in with the other data, has triggered a warning on our Microdochium disease model. So that's kind of the area that we're heading to. So we're looking for the 3 disease models that we've been working on, first quarter of 2025, anthracnose, dollar spot and Microdochium disease models to be released as part of our Pro Data reporting software. Thanks for watching the presentation. Anybody who has any questions pertinent to it or anything else weather related, weather station related, please feel free to drop us a line. Socials and emails will be tagged at the end.